Galaxy Fighter. This lesson is called the depot. Our task is to let the depots fly across the screen, and when the ship touches them, the ship is powered up. For this, we need collision detection. The ship and the depot have bounding boxes, and we can use the function cgrect_intersects_rect to decide if two bounding boxes overlap, and register that as a collision. If you look at the image here, you see that those two bodies have not collided at all, even though their bounding boxes tells us that they have. So what we need is a method to tweak this. One simple way to do it is to shrink those bounding boxes, like here. But how do we shrink the bounding boxes? We can use a function called cgrect_inset, which takes a rectangle and two floats, and returns a shrinked rectangle. Let's go to Xcode and see how we can use this. We are inside Xcode. Our task is to add the depots, which will act like power-ups, and let them fly across the screen. When the ship touches a depot, the depot disappears, and the power-up sound is heard. Our plan is to treat the depots like planets. We will create a Depot Manager class and also introduce collision detection by creating a Collision Manager class. In this lesson, we will add two new resources: an image of a depot, which we will add to the sprite sheet, and a power-up sound. Before embarking on this tutorial, you might want to take a look at these free tutorials from my website: the Sound Sorcery tutorial and the Simple Collision Detection tutorial. Let's look at our starting point. We have our sprite sheet here. And as you can see, we have added the depot image here. And also, if you look in the sounds, you will find the power-up sound. Let's play it. That will be the sound when the ship powers up from the depot. Let's look at our code. We begin by looking at GameLayer.h. And we see that we are introducing two new classes here: Depot Manager and Collision Manager. And here are the corresponding instance variables. If we go to the implementation file, we are importing the headers of those two classes. Let's look in the init method. We are creating the Depot Manager and the Collision Manager. In the update method, there are two new lines. We are sending the update depots to the Depot Manager and also update collisions to the Collision Manager. Let's take a look at the Depot Manager class. The interface file looks exactly as that for the planets. The Depot Manager is a subclass of the Fly Manager, and here are the four required methods. In the implementation file, we have some constants. In the init method, we are setting next depot time to 0, just like we did for next planet time. But when creating the sprite array for our depots, there is a difference. When we created the planet array, we had to provide the planet names as a parameter, because all the planets were different. But when it comes to depots, we have just one image, depot.png. What we have to specify instead is the maximal number of depots that can be present on the screen at the same time. In our case, we will never have more than 5 depots present simultaneously. Regarding the Z order, we will put the depots above the planets, we have arbitrarily chosen the number 20 here. Let's take a look at this new method. It is in the sprite array class. Here is the declaration. Let's see how we implement it. It is very similar to what we use for planets. The only difference is that we are now looping from 0 to capacity. Let's go back to the depot manager. The update depots is just calling the superclass, just as we did for the planets. The required methods are identical to those for planets, except for next delta time. The random time here is chosen differently depending on what level we are playing. As you can see here, the random time is taken as a random number between frequency and 1.5 times frequency. But this frequency varies with the level. As the level increases, the frequency decreases, meaning that the depots are generated more frequently. The level is now defined in the common class. It is temporarily set to 1 for testing purposes, but will in the future correspond to the real level that the user is playing. Let's go back. Observe also that we use the clamp f function, so that there will be a certain minimum value for the frequency that will not be passed. That's all for the depot manager. Let's now take a look at the collision manager. In the interface file, we see that the collision manager inherits from NSObject. As expected, it has a method called update collisions. Let's look at the implementation of this method. The only thing we do here is to check if depot hits ship. If so, we will return. Otherwise, we will continue below here and check for other collisions in the future, like if the meteors hit ship or if the laser hits alien, and so on. So this will become larger and larger as we develop our game. But for now there is only the depots. And the depot hit ship method is here. It loops the whole depot array, checking one depot at a time. If the current depot is not visible, we just take the next depot. If it is visible, we check if the bounding box of the ship and the bounding box of the depot intersect. Well, technically not the bounded boxes themselves, but the inset bounding boxes, which are a bit smaller than the real bounding boxes. If they don't intersect, we return no. Otherwise, make the depot invisible, play a sound and return yes. That's everything there is to it. So let's run this and see if it works. And as you can see, it works. Thank you for watching.